Hi students, so welcome you all for the class, that is our functions chapter. So we can begin our class with our topics where we have left yesterday. Clear? So yesterday we have covered some very important topics about functions. Identity function and constant function are over. So now we have to go for the next function. Clear? So yesterday we also covered some functions definition, and we have gone through in depth knowledge of what is function, how the function is going to be defined, and how to identify the function. Those all things we have studied, and we have gone through some important functions like identity and constant. So today we have to continue with some other functions which are very important. Okay, so that is, first one is polynomial function. First one is polynomial function. Clear? Okay, so see here, before going to polynomial function, good afternoon to everyone, and be safe and be at home. Take care of your family as well as yourself. Please be at home. Okay, if you be at home, you will be very safe. If you go out of home, there is no guarantee that you are going to be safe. Clear? So now we can start our chapter, or our concepts, that is polynomial function. Okay, so you just see here, what is polynomial function? Polynomial function, a function f from R to R, that is real numbers to real numbers, is said to be polynomial function, if for each x in R for each x in R, y equal to f of x is equal to a0 plus a1x plus a2x square, so on to plus an x raised to n, where n is a non-negative integer and a0, a1, a2, so on to an are your real numbers. So I think here you not need any more explanation, because if the function is defined from real numbers to real numbers, and here you can just see f of x is written as the polynomial, that is a0 plus a1x plus a2x square plus a3x cube plus so on to, it goes for an x to the power of n. And here the very important thing is your a0, a1, a2, a3, so on to an. These all are the coefficients of x. These are the coefficients of x, and they must be real numbers. Okay, and also you can just see here, n is non-negative. Okay, why? Because if n is non-negative, then this is going to be defined. If it becomes negative, what happens? X to the power of minus 2, it will be 1 by x square. Okay, so that's why the n must be non-negative. The n must be non-negative, because these things are not allowed in polynomial function. Clear? So I think you have understood this, because already you all know that f of x is equal to a0 plus a1x plus a2x square plus a3x cube plus so on to an x raised to n is called polynomial, and you have already know about the idea of polynomial. Anyways, you have solved the algebraic equations like ax square plus bx plus c equal to 0. So this type of problems already you have solved, where it is called as algebraic equation where it is called as algebraic equation, and it is the subtopic of polynomial. It is the subtopic of polynomial. Okay, so like this you have already studied about algebraic equations, cubic equations, and equations with the fourth root. All you have studied, so here you don't need more explanation. So let us go for the next concept. Okay, so this is called your polynomial function. So now let us see the examples of polynomial function. So here you just see, that is f of x equal to x square. It is defined from R to R. So you can see that this is x square. It is polynomial function. Okay, because if the function is in the form of a naught a1x plus a2x square plus a3x cube plus so on, we say it is polynomial. Okay, so you can see that it is in this form. Clear? Here you have written only a2x square, where a2 is 1 and the remaining all terms are 0. Okay, so I think you can understand that. So here this is polynomial function, remaining all terms are 0. This is also 0, only you have a2x square, where a2 is equal to 1, where a2 is equal to 1. Clear? Okay, so this is your polynomial function. Now let us see what happens with this polynomial function. Clear? Okay, so you just see here, it is defined from real numbers to real numbers. It is defined from real numbers to real numbers, and domain is real number set, codomain is real number set. Now you can just see, if I put minus 4 in our function, if I put minus 4 in our function, what you are going to get? See here, x value is minus 4. If I take x value as minus 4 square will be what? 16. Okay, next minus 3 square, put here minus 3 square will be what? 9. Put minus 2 square will be what? 4. Minus 1 you put here, minus 1 square will be what? 1. You put 0 square will be what? 0. 1 square will be what? 1. 2 square will be what? 4. 3 square will be what? 9. 4 square will be what? 16. So are you getting my point? So now you just see these are the outputs of this, some small examples. So now from this you can draw y-axis, you can draw x-axis. So here I will take minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. Okay. So here I will take 1, 4, 9 and 16. I will take this as 1, 4, 9 and 16. Just to get the nature of the graph. Just to get the nature of the graph, 1, 4, 9, 16. So at 1, see here, at 1 output is 1. So this is the point, no problem. At 2, 4 is the output. You just see here, this is the point. At 3, see your point, this is 9. At 4, see your point, this is 16. Okay, on the same way, at minus 1 output is 1, at minus 2 output is 4, at minus 3 output is 9, at minus 4 output is 16. Okay, so now if you join this, it will be in the form of this curve. Okay, so here it will not have sharp edge, it will have smooth edge. Not sharp edge, it will have smooth edge. Okay, so this will be the nature of graph. This will be the nature of graph. Okay, so now you can just see here, see this, the nature of graph. Both are going to be similar. Both are going to be similar. Okay. So here this is a rough diagram that I have drawn. This is a rough diagram which I have taken here. So on the same way, you can just see here, this is a very much good diagram that you can see. It will be with the form of upper curve. You can see that there will be an upper curve like this. Okay. So now from this, what you can tell? Can anyone tell me the range of this? So quickly, can tell me anyone what will be the range of this? If you tell the range, then you are on the right path. If you tell the range, you are on the right path. Quickly tell me what is the range of this particular term. Okay. So 16, 9, 4, 1, 0, 1, 4, 9, 16. I am asking the range of f of x equal to x square. I am asking f of x is equal to x square range. So quickly tell me what is range. What is domain? What is codomain? Very important point. F is function from real numbers to real numbers, defined as f of x equal to x square. Defined as f of x equal to x square. So now I need range. Now I need range. So as I said, the range is collection of images. As I said, the range is the collection of images of your domain term. As I said, the range will be the collection of your domain term. Are you getting my point? Why all of you are telling range as 0? I don't know. Range as 0 means, see here in your graph, if you are telling it as 0, then it should be only one element. It should be constant term. If it is 0, the graph must be here only. Okay. It is not only 0. It is not only 0. There is some another term. There is some another term. That is positive real number set union with singleton set 0. Positive real numbers with union of singleton set 0. Are you getting my point? Domain is real number set, no problem. Domain is real number set, no problem. Codomain is real number set, no problem. Okay. So now the range is positive real numbers with singleton set 0, because you see the collection of images is called range. So collection of images will be on which axis? Y axis. So see here, every point of y axis is having the image. Every point of y axis is having an image. So that's why the curve is possible. Okay. You can take any point on the y-axis. For that there is a graph. Okay. So that you can just see here. In the graph you can just see from 0 to infinity on the positive y-axis. You just see here, for 0 there is a line. For this point there is a line. For this point there is a image. For this point also there is a image. For this point also there is a image. You can take any point on the y-axis. For every point there is a corresponding image. You can take like this. It go towards positive infinity. And it starts with 0. So you can write it as, in clear, if you want to write it as, you can take it as closed at 0, open at positive infinity. So this will be your range. So please remember, closed at 0, open at infinity. You can see in the diagram. you can see in the graph, it is starting from 0 and it is going towards positive infinity. Okay, so that's why we say that it is starts with 0. See here, it starts with 0 and go towards positive infinity. So that's why closed at 0, open at infinity is the range. Open at infinity is the range. So please remember everyone, very very important, and this is going to be asked in so many times in your exams. This has been asked in so many times for your exams, CET, JEE mains, as well as your what? Your board exams. Okay, so that's why I am telling this is your range. This is your range, and please be perfect with the nature of graph. Please be perfect with the nature of graph. Are you getting my point? So once you get a perfect with the nature of the graph, because it will be very helpful to solve the shortcuts. So that's why I am telling you have to be perfect with the nature of the graph. Clear? Okay, so I think all of you have understood this. Here the domain is real number set, codomain is real number set, range is closed at 0, open at infinity, and therefore the polynomial function is defined as f of x equal to a0 plus a1x plus a2x square plus a3x cube plus so on to an x to the power of n. So quickly tell me, all of you, how many of you have understood this? Quickly reply me, how many of you have understood this? Next, I has to go for f of x equal to x cube. This is also polynomial function, f of x equal to x cube. Okay, so this is also polynomial function, so I has to go for f of x equal to x cube. Okay, see here, this is x value, this is f of x value. If I take x value as minus 4, can you tell me what is f of x? That is equal to x cube. Can you tell me what is f of x? That is equal to x cube, or you can also write it as equal to y. Okay, so minus 4x cube, you just see what is minus 4x cube, that is going to be minus 64. So that means this is minus 64. Okay, take minus 3, output will be what? Minus 27. Next, minus 2, output will be what? Minus 4. Sorry, minus 8, not 4, minus 8. So this is minus 8. Okay, next, minus 1 will be minus 1, 0 will be 0, 1 will be 1, 2 will be 8, 3 will be 27, 4 will be 64. Clear? So these are going to be the outputs for f of x equal to x cube. Okay, so now here you can just see the diagram, that is the nature of your particular function f of x equal to x cube. See here, f of x equal to x cube, nature of the graph. Nature of the graph will be like this. Okay, clear? So from this, if you understand the function, if you understand the nature of the graph, by looking at the nature of the graph, quickly tell me what is range. Now by looking at the graph, from graph, what is range? Quickly tell me, anyone. Quickly tell me, anyone. You have to see the graph and you have to tell me the range. I will see how many of you can tell it, because already in the previous in the previous graph I have explained how to identify the range. So now please identify the range and tell me. Quickly you can identify and tell me the range, no problem. Okay. So range is not integer. Range is not integer because integer means only plus 2, minus 2, plus 1, minus 1. See here, my dear students, if integer means, see the graph first. Here we have taken integers, no problem. Here we have taken integers, but no problem. You see the graph, nature of the graph. I can take here minus 1 by 2 also. I can take here minus 2 by 3 also. Are you getting my point? I can take here minus 3 by 6 also. Okay, so that's why you just see the diagram. Just see the diagram. Here I can also take 1 by 2 also. Here I can take 2 by 3 also. So that's why please see, only integer is not your range. You just go through the previous diagram. What you have seen? You have seen each and every element of y-axis. From this you have seen the corresponding graph. Okay. So from that you said it is 0 to positive infinity. Clear? So now by coming to this, you just see here, it starts from 0, it is going towards negative infinity. You can watch here. The graph is going towards negative infinity. Here the graph is going towards positive infinity. From 0 to positive infinity. Okay. On both sides you have the nature of graph. Are you getting my point? That means for every value of x, you have corresponding term on y-axis. Are you getting my point? So now you tell me, using these hints, what is the range? Range is equal to, because I want answer from your side. You just see it is going towards negative infinity, it is going towards positive infinity. So from negative infinity to positive infinity, the complete graph is present. See this. Complete from positive infinity to negative infinity, there is a graph. Okay. So if the graph is present, the graph is nothing but the collection of images. The collection of images is called what? Range. So see here, from negative infinity to positive infinity, there is a graph. So that means it is from negative infinity to positive infinity. It is from open at negative infinity, open at positive infinity. This is your range. That you can tell it as real number set. Okay. Domain is also your real number set. Codomain is also real number set. Okay. So that means here you remember one note. If you know the graph, from graph you can tell the range. Okay. You no need to solve anything. From looking at the graph, you can tell the range. Clear? That means another note is, Watch the graph carefully. Watch the graph carefully. Watch the graph carefully. Carefully, and you see the points. You see the points from where to where. From where to where. For example, you can see here it is from minus infinity to positive infinity. If it is from minus infinity to positive infinity, where to where means you can see here from minus infinity to positive infinity. It is showing us the range. It is showing us the range. Are you getting my point? So with this type of tricks, these all are tricks to identify the range. These all are the tricks to identify the range. Okay. This is also trick to identify the range. Clear? So by using this type of small tricks, you can give very wonderful results. In a quick seconds, 2 or 3 seconds, you can tell what is the range of f of x equal to x cube. Okay. So for that you must know the graph. For that you must know the graph. So now I seen the graph. From that I can tell the range is from minus infinity to positive infinity. That is real number set. That is real number set. Okay. So I think you have understood this polynomial function f of x equal to x cube. For f of x equal to x cube, the range is real number set. For f of x equal to x square, the range is closed at 0, open at infinity. Please observe here. All graphs, all functions will have different ranges and different graph. Are you getting my point? All the functions will have, the different functions will have different ranges. Different functions will have different ranges. Are you getting my point? Okay. So this is all about f of x equal to x cube. So quickly tell me how many of you have understood this. So quickly tell me how many of you have understood this too. Okay. So today I will take one class. I will take one more class at 9 p.m. One more class at 9 p.m. Here I will explain strategies. First thing is strategies about timetable. Third one, CET. Fourth, JEE mains exam. Clear? And fifth, how to study both for board exam and CET. For both board exam and CET. Okay. So this is going to be very important. This is going to be very important. Clear? Because from tomorrow I am going to take CET classes. From tomorrow I am going to take CET classes. Okay. CET classes. Clear? So in this class I am going to discuss about time. Time means at what time I should engage the class. I should engage this CET class. CET class. And the classes which I am taking is all for free. These are the free CET classes what I am going to engage on my side. These are not from our college side. This is on my own interest for my students. Okay. So these are free CET classes. Every day it will be. And the paid class will be only on Saturday and Sunday. For that all is all about your college side. So from college side I am taking from Saturday and Sunday, and leaving that 2 days, the another 5 days I am taking free CET classes. So about that I am going to discuss at this 9 p.m. So there I am going to work on this all particular things, and I am going to discuss about all these things. And so for that's why I am asking. So all of you has to attend for that. All of you has to attend for that. And some important things I am going to discuss. Okay. So for this all things, if you want to know, you just attend my this 9 p.m. class today. Don't worry, I will share the link. Don't worry, I will share the link. In that I will give all the details of link, what I am going to discuss and how the classes are going to be. All things I am going to give in that. Don't worry. So you have to attend that 9 p.m. class. That is important. So tell all your friends about this, what I have explained you. So they can also attend this class. Clear? Okay. So now let us come to our chapter. Let us come to our chapter. That is example 15. So my dear students, you just see here example 15 is not your polynomial function, is not your polynomial function, is not your polynomial function. It is called rational function. It is called rational function. Okay. So then what is rational function? That comes to your mind first. So first we shall understand what is rational function, and next we shall understand what is example 15. Are you getting my point? First we shall understand what is rational function, and next we shall understand what is example 15. If you know what is rational function, then only you can understand example 15. Okay. So for that reason I will explain first the rational function. See this rational function. See this rational function. The function f from R to R, the function f from R to R is given by f of x is equal to 1 by x. The function f from R to R is given by f of x is equal to 1 by x. Okay. Sorry, f of x is equal to not 1 by x, f of x is equal to p of x divided by q of x. P of x divided by q of x, where q of x is not equal to 0. Where q of x is not equal to 0. And p of x and q of x are polynomials. Okay. So here p of x is polynomial, q of x is polynomial, and f of x, if defined in the form of p of x by q of x, is called rational function, and where q of x is not equal to 0. And where q of x is not equal to 0. Okay. For this the example is example 15. For this, the example is example 15. Okay. So example 15 gives us the idea about rational function. So here you must know the rational function will be in the form of p of x divided by q of x. P of x divided by q of x, where p of x and q of x both are polynomials and q of x is not equal to 0. Q of x is not equal to 0. Okay. So now from this you can see this is called polynomial function, and now we can go for example 15. You see how the example 15 is defined. Example 15 is defined as f such that r minus singleton set 0 to r. R minus singleton set 0 to r. This is domain and this is codomain. Okay. Let us see the range from the graph. Clear? So domain is r minus singleton set 0. Codomain is real number set. So now you can see the function is defined by f of x is equal to 1 by x, where x cannot be equal to 0. So that's why in the domain they have given r minus singleton set 0. That means in the complete real numbers, from the set of complete real numbers, they are taking out this 0. Okay. From the complete real number set, if they take this singleton set 0 outside, then this is called non-zero real numbers. Please remember this, because in this real number set 0 is not present. So that's why it is called non-zero real number set. Clear? So domain is r minus singleton set 0, or you can also say it as non-zero real numbers. So now you can tell the domain is non-zero real number set and codomain is real number set. Then what about range? So for that you can see this graph. Okay. So from this you can understand what is the range of this function. Clear? So can you tell me what will be the range of this function? Anyone? Can anyone tell me what is the range of this function? Quickly, from the diagram you have to tell. What is the range of this function. So quickly tell me. What is the range? So you just go through the graph. And from that you can tell, no problem. Very good. Shreya is giving the right answer. So range is going to be real number set, the complete real number set except 0. That means range is equal to non-zero real number set. Okay. Very good. So most of you are giving the right answer, and this is the nature of the graph. You have to remember, very important. Okay. So here we have gone through f of x equal to x square, f of x equal to x cube, f of x equal to 1 by x, and we have also seen f of x equal to c, and we have also seen f of x is equal to x. Okay, so quickly tell me, f of x is equal to x is which function? F of x is equal to x is which function? Quickly you have to reply. F of x equal to x, you have to reply. What is the function f of x equal to x? So tell me as soon as possible. And what is f of x equal to c? What is f of x equal to x square? What is f of x equal to x cube? What is f of x equal to 1 by x? So all of these functions, their domain, their range, their codomain, as well as you can see their graphs. Okay, graph, range, domain, codomain, these all things you must understand. You must have them in your notes. That means that you have to remember them with 100%. They are very important. Okay, so what I have written here for them, you have to remember their domain, their range, their nature of graph, and they are called which function. You have to remember all those things. If you remember all those things, then it is going to be very good for your exams. So now let us go for modulus function. So you just see here, the function f from r to r is called modulus function f of x is equal to mod x. And most of the students, 99% students knows that for mod function, for modulus function, output is always positive. Output is always positive. But my question is why? Why the output is always positive? That is very important. So why it is going to be positive? That is a very good question, you know. So that's why most of the students knows that modulus function is positive. But my dear students, please remember, the concept is important. Result you know, no problem, but the concept is important. Why the modulus function is always positive? Let us study now. Why the modulus function is always positive? Let us study now. Clear? So modulus function is given by the function f from real numbers to real numbers, and f of x is equal to mod x, but the story is different. It is x if x is greater than or equal to 0. It is minus x if x is lesser than 0. This is the real story. Okay, so no one tell the real story. Always they give build-ups. Okay, so that's why before you get in a build-up, you must have a nice story behind the scene. Clear? So like that, modulus function has one real story, that is, whenever you have x is greater than or equal to 0, it is reacting like x. It reacts as x. Whenever x is lesser than 0, it reacts like this, as minus x. That means modulus function has two phases. Modulus function has two phases. One for positive inputs and another one for negative inputs. So it acts with one phase whenever x is positive, and it acts with negative phase whenever it is negative. Clear? So if I say, if I take f of 1, here 1 is positive. See here, if I put 1, mod of 1, it is positive, output goes to here, output will be 1. Okay, so f of mod 1 will be 1. But when I put minus 1 to this, it goes to the second phase where x is lesser than 0. Where x is lesser than 0. See here x value, put x value. What is minus 1? So f of minus 1, mod of minus 1 will be what? Minus x. That means minus of minus 1, that will be plus 1. So because of this it is getting minus of minus 1, so it is getting plus 1. Therefore the negatives also becomes positives. The negatives also becomes positives. Okay, so that's why I am telling the negatives become positive because of this second phase of modulus function, second phase of mod function. Okay, so mod function has two phases, one for positive and another one is for negative. Whenever you have positive entry, it will act with positive phase. Whenever you give negative entry, it will give with negative phase. Okay, so that's why the output will be always positive. That's why the output will be always positive. That you can see here. F of x is equal to x if x is greater than or equal to 0, minus x if x is less than 0. So I will take f of 2. 2 is positive, so it goes here. So that will be x value is 2. If I take f of minus 2, take minus 2, it goes here and it comes here. That is minus of minus 2. X value is minus 2. So minus of minus 2 will be what? Plus 2. In the place of x, you must write minus 2. So minus of minus will be plus 2. Okay. So that's why I am telling whenever it is positive, it acts with positive phase. Whenever it is negative, it acts with negative phase. So that's why mod function is, that's why the mod function is always positive. Always positive. Clear? So quickly tell me how many of you have understood this? How many of you have understood this? So now going for range. What is range? Domain you know, codomain you know. Domain is real number set, codomain is real number set. Range I want. What is range? And this is the graph of modulus function. This is the graph of modulus function. Okay. So now with this modulus function, you can tell me the range. That is positive real number set. Positive real number set. Real number set with 0. That is R plus union singleton set 0. R plus singleton set 0. That is closed at 0, open at infinity. This is the range of some another function. What is that? This is also the range of f of x is equal to x square. So that means f of x is equal to x square and f of x is equal to x both have same range. F of x is equal to x square and f of x is equal to mod x, not x, mod x. Both have same range. Both have same range. Okay. Clear? Very good. So all of you are giving the right answers. So that means concepts are getting cleared. Concepts are getting cleared. So if I finish this two, so I can end this functions topic. Okay, no problem. So quickly I will finish this two and I will end this chapter. Now let us go for Signum function. Now let us go for Signum function. F is defined from real numbers to real numbers and f of x is defined as 1 if x is greater than 0, 0 if x is equal to 0, minus 1 if x is less than 0, That means it has three faces. Signum function has three faces. It is very essential to identify the number of faces of every person. Every person has more than one face. If we want to be good with him, we have to understand all the faces. Then only we can become the good friends. Please understand. If you want to become a good friend with anyone, first you understand all the number of faces what he has. In front of you, what he act. In whenever you are not in front of him, how he act. And whenever is with those people who hate you, how he react. Whenever he is with the people who you like, how he react. Those all faces has to be identified. Then only we can become the good friends. Okay. So that is what the psychology tells. Clear? Here also the same thing. Signum function has three faces. The signum function is defined as f of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, minus 1 if x is less than 0. That means if you give the positive inputs, output will be 1. If you give the positive input, output will be 1. If you give 0 as the input, output will be 0. If you give 0 as the input, output will be 0. If you give negative input, output will be minus 1. So that means it has only three outputs: 1, 0, minus 1. 1, 0, minus 1. So this is going to be the range. Only three elements. That is positive 1, 0, negative 1. This is the range. And this is the definition of signum function. F of x is equal to 1 whenever x is greater than 0. Equal to 0, it will be 0. Lesser than 0, it will be minus 1. That means when you show the positive thing, it reacts as 1. When you give 0, it reacts as 0. When you give negative input, it reacts as minus 1. So that you can see here. Whenever you have positive inputs, for that it is fixed for 1. For all positive x values, it is fixed for 1. For all negative values, it is fixed for minus 1. It goes like this. And for 0, it is fixed at 0. Okay. You can see here. On y-axis, it is fixed for minus 1 for all negative x values. For all positive values, it is fixed for positive 1. Okay. And for 0, it is fixed for 0. Clear? So this is your signum function. This is your signum function, that is f from R to R defined by f of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, minus 1 if x is lesser than 0. Clear? So this is your signum function, and range is minus 1, 0, plus 1. Minus 1, 0, plus 1. Clear? Very good. From signum function, we can learn very important thing about how to understand the people. Okay. So next, the last one is greatest integer function. And the last one is greatest integer function. Okay. So my dear students, see here, greatest integer means, first I will draw real number line. This is negative infinity. This is positive infinity. This is 0. I will take 1 here, I will take 2 here, and I will choose any number in between 1 to 2. I will choose any number in between 1 to 2. I can take any number. You can take 1.9, you can take 1.8, you can take 1.7 or 1.8, 1.7, 1.2, 1.3, any number, and greatest integer of this. How to solve greatest integer of this? Say x belongs to integer and x is lesser than or equal to 1.9. That means see here, the greatest integer which is lesser than 1.9, that is called the greatest integer of 1.9. Please understand this. If I want to find the greatest integer of 1.9, what you have to check? If I want to find greatest integer of 1.9, what I has to check? This is 0, this is 1, this is 2. I will take this is 1.9. Okay. You have to check from this line lesser than or equal to 1.9, and among this all, which one is the greatest integer? Here you have 2, -1, -2, -3, -4, so on. Okay. Among all these integers, which one is the greatest? Which one is the greatest? That is called greatest integer of f. That means greatest integer of 1.9. So can you tell me the answer? Among all this, what is the greatest integer of 1.9? Quickly tell me. Very good. So this is 1. That means greatest integer of 1.9 is 1. Greatest integer of 1.9 is 1. What is greatest integer of 2.9? What is greatest integer of 2.9? I am asking about 2.9. What is greatest integer of 2.9? Very good. For 1.9 is 1. Then what is for 2.9? What is for 2.9? Very good. 2. What is for 1.1? What is for 1.1? What is for 1.1? I am asking 1.1. Very good. 1. Okay. So now let us draw the graph. Say this: 0, 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. See here, my dear students, in between 0 to 1, I can take any number. Output will be what? 0. Output will be what? 0. If I take any number in between 0 to 1, output will be 0. In between 1 to 2, I can take any number, it will be 1. In between 2 to 3, I can take any number. This is 1. 0 to 1, this is 1. 2 to 3, 2. 3, 4. Okay. 2 to 3, it will be 2. 3 to 4, it will be 3. And here, minus 1 to 0, take minus 0.9. Which one is the greatest integer of minus 0.9? What will be the greatest integer of minus 0.9? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Here 0.9. Minus 0.9. Lesser than this. And the greatest integer, it will be minus 1. Okay. From minus 2 to minus 1, it will be minus 2. Not 0. See, not 0. Not equal to 0. This is not equal to 0. Because you have to check lesser than or equal to minus 0.9. This is 0.1, minus 0.2, minus 0.3, minus 0.4, minus 0.5, minus 0.6. This will be minus 0.9. Lesser than this, it goes left hand side. Lesser than this means minus 1, minus 2, minus 3, minus 4, minus 5. Among this, which one is the greatest one? Minus 1. Okay. What is greatest integer of minus 1.9? What is the greatest integer of minus 1.9? This is minus 1.9. Okay. So what will be the greatest integer of minus 1.9? I am asking about minus 1.9 now. Clear? So what will be the greatest integer of minus 1.9? The greatest integer of minus 1.9. Very good. Minus 2. Clear? So this is how in the JEE mains and even our Karnataka CET they are going to bluff you. Okay. So you will be knowing this concept and they will make you to confuse in this type of concepts. So that's why first you understand these concepts very carefully. Then if you understand these concepts very carefully, then you can answer, no problem. What is greatest integer of 1.9? Say, what is greatest integer of 1.9? Greatest integer of 1.9. Quickly tell me. Very good. 1. See these two examples. See these two examples. If you know the concept, then you can answer correctly. If you know the concept, then you can answer correctly. Are you getting my point? If you don't know the concept, in such type of things, they will bluff you and they will make you to not get the marks. Okay. So you understand here, and you can see that the nature of graph will be like this. And outputs, you can see outputs are always integers. Outputs are always integers. If the outputs are always integers, then what is the meaning? The range is integer set. The range is integer set. Clear? So now I will remove all these things. Come to this one, and you can see here I will remove all these things. See the graph. See the graph. Okay. This is the graph of greatest integer. And my dear students, please see here, the gap is called jump. Okay, we say it as jump. Clear? The gaps are called as jumps from one to, you can see here, these are called as the gaps. These are called jumps. Okay, say this. These things are called as jumps. Clear? And it is called stepwise graph. It is called stepwise graph because it look like steps. Okay, so it is called stepwise graph. Clear? I think you have studied limits. Next you will learn continuity, and next you learn differentiation. Next you learn differentiation. If you know this nature, in this continuity and differentiability, just by looking at this graph in 1 second, you can answer one page question, one page solution. You can just solve in 1 second. One page solution you can just solve in 1 second. That is in your 12th class. Okay, so this 1 second is important. If this 1 second is important, the nature of graph is important. Clear? So therefore, this is how the graphs are going to play very important role, because in 12th class you are going to learn determine continuity of given function. Okay, this takes you 5 minutes to solve. This is of 12th class. Okay, if you know these graphs, it takes 1 second. So this type of things you are going to study in your 12th class. So that's why the definition of function, the domain of the function, the range of the function, the nature of the graph of the function, these all things you have to remember. Okay, so from this I think you have understood what is the greatest integer function, and you also understood what is the nature of the graph. So from this, these things you need for your 12th class, so that I can tell here, if you know this much, it is enough. Okay, so I can end this chapter here only, no problem. Or rather, there are some questions like solving for domain and range. If we solve that, then it is over. Clear? Okay, so now see, first question, definition of functions. Second one, range of functions. Third one, nature of graph of the functions. Very important. Okay, so what all functions I have explained, what all nature of the graph I have given, and what are all the ranges that I have given. You have to study all those things, and you have to keep them in your mind, and you have to revise those things very oftenly. So I will end this functions chapter here. Okay, I will end this functions chapter here. So these basics that you need for 12th class are very important. So From the next class we shall see what happens. From the next class we shall see what happens. So today 9 p.m. I am going to discuss all about your next classes, all about your CET classes. So that's why let us discuss about the next classes in your next 9 p.m. It will be at 9 p.m. Okay. Today it will be for both 11th and 12th class. It will be for both 11th and 12th class. Okay. So thank you everyone. Be safe, be at home, take care, and let us join in the next class, that is at 9 p.m. Clear? Okay. Thank you and bye.